We have two main types of sequences that we talk about, and that is arithmetic sequences and geometric sequences. And they have to do with the graphs that we noticed at the end of the last video. Now, here's our summary. An arithmetic sequence means that you are adding or subtracting the same number over and over and over in the pattern. That number that you're adding or subtracting over and over, we call D, or the common difference. Excuse me. A geometric sequence is if you are multiplying the same number over and over and over. And that number that you are multiplying, we call R, or the common ratio. And these are our two big sequences that we talk about. Now, we're going to take the same 9 sequences that you started the lesson with, and I identify them as arithmetic, geometric, or neither. So, let me give you this example in this first line. If you're adding the exact same number over and over, or multiplying the exact same number over and over, we have arithmetic or geometric. If you're not doing either of those patterns, then it's neither. So this first one, for A, we are not adding the same number over and over or multiplying the same number over and over. So this would be neither. However, if I look at E, this one we were dividing by 2 over and over, which we also talked about was the same thing as multiplying by 1/2. So this is geometric. And our R that we're multiplying over and over to get to the next term is 1/2. And then an example of an arithmetic would be D. In D, we're adding 3 over and over and over. So since we are adding the same exact number over and over, that is arithmetic, and we say that the number we're adding over and over is a positive 3. So with those 3 examples, pause the video and try the other 6, if they're arithmetic, geometric, or neither. If they are arithmetic or geometric, list what D or R is. Let's check your answers. I got neither for all 3 in the first row because we're not adding the same number, subtracting the same number, or multiplying the same number every single time. We already did these 2. This one is arithmetic because we are subtracting 5 over and over. This one is geometric because we're multiplying by 2/3 over and over. This one is neither. And this one is geometric because we're multiplying by -3/2 over and over. So let's start right here. Let's determine if the following sequences are arithmetic, geometric, or neither. So what we're going to do here is make our t-table again, just like we did when we were graphing. And we're going to find the first few terms just by plugging this in. So I'm just plugging in n. I'm going to make n green. 1, 2, 3, 4. Make it stand out a little bit to show that that's what I'm plugging in. So I get 2 times 1 plus 1 is 3, 5, 7, 9. So here is my sequence. Now I see if I'm adding, subtracting, or multiplying the same number over and over to see if it's arithmetic or geometric. And you've probably noticed that we are adding 2 every time. So this is arithmetic with D a positive 2. So having done that first example, I would like you to pause the video and try these other 2 examples. Make your t-table, plug the numbers in, and then look at your answers to see if you can see those patterns. If you're also very clever, you'll notice you have already done these 2 in the graphing portion. So if you want to just grab the answers from that part of your notes, you're more than welcome to. So pause the video, try those 2 out, and then come back to check your work. let's check your work. So that one I just pulled from example 3A, my answers. That is neither. I'm not adding, subtracting, or multiplying the same number over and over. This one, I pulled the answers from 3B, and I am timesing by 1/3 to get each answer. So that is geometric with R is 1/3. Now, for the last part of this video, let's go over two formulas that are on your reference sheet. These formulas are the explicit formulas for arithmetic and geometric sequences. So as soon as you know if it's arithmetic or geometric, you just have to find the things you need for this formula, plug them in, and you have an explicit equation for that formula. Now, once I said, like I already said, these are on your reference sheet. You don't need to memorize them. You just need to know how to use them. So let's use them in example 6. First, in being able to use them, is we need to identify if it's arithmetic or geometric so I know which equation I should use. So this one, it looks like I am adding 5 every time. So this is going to be arithmetic, which means I'm going to use this pink equation. So I need to know what a sub 1 is, the first term. Well, the first term in this sequence is -6. And I need to know what d is. Well, I am adding 5 every time to get d. And now that I know those two, I can write my equation out with my first term plus d times n minus 1. And there's my equation. So let's say I wanted to find out what the fourth term is. Should be 9. I plug 4 into here. I get 4 minus 1 is 3. 5 times 3 is 15. Minus 6 does give me 9. So I can plug any term into this equation and get the answer. I don't need to know the ones before it. That's what makes it an explicit formula. So let's try B now. Let's see. All right, sorry guys, I had a typo in my notes. This should be this. I accidentally, when I was printing off your notes, just copied and pasted A again. It should be that. So if I have this, I will notice I am timesing by a -2/3 to get to the next numbers. Now, since I'm multiplying by the same number over, that means it's geometric. So I need to use this green equation. So I need to know what G1 is. My first term is -5. And I need to know what R is, which is -2/3, what I'm multiplying by every time. Then I can just plug everything into my equation here. -5 times -2/3 to the n minus 1. And that is my explicit formula for a geometric sequence. So that is how you come up with explicit formulas for arithmetic and geometric. Explicit formulas for non-arithmetic and geometric are a much harder thing to do, and you will not have any of those on your test or final. So these are the two that we will be focusing on the most. In the last video for today, we're going to be using these formulas and everything we've learned in the lesson today to solve some application problems about these sequences.